Hello, everyone! Chapter 3, Learning Target 1. Oh my goodness. This is Miss Ozier.
And Miss Lahar.
And here we go. So we are now bringing it on back to functions. So this is a chance for you to catch your breath if exponents and logs were a little bit rough for you.
Ready? We're going to have some fun with functions.
I like it. That was a good one. That was total improv. We didn't even plan it.
Nope.
All right, ladies and gentlemen. So a function is a rule that assigns exactly one input value,
which are your x's,
for each output value,
which are your y's.
So input x, output y. There's 3 ways to represent a function: equations,
Good old equations,
graphs,
beautiful looking graphs,
and tables.
awesome tables.
Basically, they all can be the same thing. They all represent a function. We call the input variable the independent variable and the output dependent. This should all be a review.
Yep. X is independent domain, yada, yada,
Yes.
yada, range is y.
We've been doing a lot of this on your weekly review.
For a function,
So-
one thing goes in,
One thing
something else comes out.
That's it. You can't hit the A button on the keyboard and sometimes have an A pop out and sometimes have an S pop out.
Right.
That means your keyboard is broken.
Okay, function notation. Now, you've seen this a little bit. Okay, you've seen it before. We know that the x in the parenthesis, that's what you're plugging in. That's the input they want. The output is the y, which is the same thing as the f of x.
Yes, don't get confused. F of x is y. They're the same thing.
The f is the rule of the function or the name of the function.
So we could call it f of x, g of x, smiley face of x, flower of x, any sort of name.
Okay, so this is what you're using notation.
And you've been seeing this on the weekly reviews. It's not like you haven't seen this ever in your life.
Okay, they can use different variables. They can use, whatever works. This is kind of old school and then the new school.
New school. Boom.
Okay.
So let's evaluate these functions. So if we're given functions, evaluate f of 3, evaluate g of negative 3, etc. The letter is telling you which function to apply it to, and the value inside is your x value, so it's what you're inputting. So if you were to evaluate f of 3, you substitute 3 into the function f,
which is linear. And
you write it pretty.
Yep, f of 3 equals 13. That is your answer.
Don't do this.
Get lazy.
Do that. We want pretty answers.
Okay.
We will mark you off. For those of you that are like, well, am I going to get points off?
Yep.
Yes, you are.
Okay, f of
Correct.
negative 2. So you plug in negative 2, do the math. That would be negative 10 minus 2. That's negative 12.
Boom.
There's my pretty answer.
Pretty answer. Super important. Okay, be careful. This is our warning with the negatives. Be careful. We talked about this in geometry. We talk about this in algebra 2. We keep talking about it. When you square a negative, make sure you put parentheses around it or your calculator will tell you this. So
Yep.
be careful.
It's not it. It would be positive 9 plus 4, which is positive 13.
Correct.
Okay, 4 squared, 16 plus 4 is 20, so g of 4 is 20.
I mean, you guys can do this stuff. 2 to the third is 8. 2 to the negative 2 is going to flip it. 1 over 4. This is all stuff that you can do.
Yep.
Okay.
All right, absolute value. Remember, your absolute value control is in the little book-looking thing, abs,
Yeah, right next to the number 9 on the calculator.
Plugging it in, you're going to get negative 21 plus 2, so that's negative 19, but the absolute value makes it positive.
Yep. Boom. We're just substituting values in. If you
Yep.
go to a radical, negative 3 times negative 7 is positive 21, minus 2 is 19, so radical 19 is your answer. Yes, you can leave it like that. We like pretty, precise, wonderful answers.
This one, again, watch out for those negatives. Put them all in parentheses. You're going to end up getting 9.
Positive 9 minus 9.
0.
Yep, something happened.
That's undefined.
This should be undefined. When you do 1 over, this should be 9 minus 9. This should be undefined because you can't have 0 on the bottom of a fraction. So just
Whoopsie.
change this negative 1 to a 0 with a line through it. Undefined.
And then we plug in the other ones. I probably did too many examples, so we're just going to scroll through those.
Boom, boom,
See, that
boom.
one gave me an undefined.
Yep.
That was right on that one.
Because you can't have a square root of a negative.
Can't have a square root of negative.
Okay,
There
we'll
you
talk
go.
about that more in the next video as well. So, for a function, it's known that g of negative 2 is 7. Which of the following points must lie on the graph? This is not hard. X, Y, people. Negative 2, 7. It's that easy.
That's the x, that's the y, so the point would be negative 2, 7.
Boom.
You just got to get used to notation. Graphically, all you got to do is look at it. So if they're g of negative 1, that's your x value.
So you find negative 1, and you go to the y value. And
So that was what they want.
Negative 4 to me.
Yep.
Boom.
So that would be negative 4. G of 0, that means x is 0, so that means the y is negative 3. G is 4, x is 4, that means the y is positive 3.
Look at that. Boom. So what values of x solve this equation? Remember, your solutions are always going to be found on the x-axis. So that's where negative 3, 1, 5, and 7 are coming from. They are where all of those answers are on the x-axis. It's where y is 0.
Yep. Remember, g of x, that's just the y value. So y equals 0 is a straight line that we just put up in red. So all those values cross right there.
Boom.
So that's why we state it. Next question is, how many values solve for g of x of 2? They don't want to know what values, how many solve it. It's where they intersect.
Yep. So you look, g of 2 would be, again, y equals 2, which is here, and I count 1, 2, 3, 4 intersection points.
So 4 values.
Boom.
Read your question.
Read your question. Don't overthink it. Have a great day. We'll see you later.
Okay. Boom.